Good morning and welcome to today's webinar. I hope that you can see my screen with my program and a welcome salute to you, and that you can hear me. Today's webinar, as you can see, the subject is the Panelrouter, and the Panelrouter is one of our built-in tools. The Panelrouter tool can, as you can read, it can help you to generate ready-to-use data to create wiring sets for panels. And how to get to that will be the secret that I'm going to share with you today. My name is Kirsten Holst, and I am in charge of all training here from PCSCHEMATIC, and with me is my colleagues. Two or three of my colleagues, my colleague David, who is a support guy, and I think that my colleague Dorte is here as well. That also means that during the webinar, it's a one-way communication, so I'm the only one speaking. But if you have questions during the webinar, you can type them in, because there's a question pane at the right side of your screen. And if you have any questions, you are very free to type them in. I'll keep one eye on them, but I think I'll keep my eyes most of the time on my screen and try to show you things. But if you have questions that come in naturally during the webinar, I'll take them there. But also, again, my colleagues are here, so they will answer you if I'm not doing it during the webinar, or we'll get back to you after the webinar. That also means that if something pops up after the webinar, you can just reply to one of the emails that we've sent you, and then they will be in our mailbox as well, and then we'll get back to you from there. And just one more practical thing, we start now at 9 o'clock, we'll finish at 10 o'clock. And I record the webinar, means that I will send you a link to the recording after the webinar. I still hope that you will stay in, but I'll send you a link with the recording, and I'll do that to those of you who are here and also to those of you who are not online right now. And that means that just if you're interested in this subject, you can see the recording once again, and you feel free to share it with anyone. So if you have co-workers that would like to see it too, just share the recording with them. So that's why we do it. So that will be it. But okay, let's go to it and see what is this Panelrouter. We have a demo file, and the demo file is called PCS Panelrouter, and it's called 1 because it's the first one, but it's the only demo that we have right now for the Panelrouter. And demo files, you find them up here. You can open the document, and then we have some different demo files in this project demo folder. So this is the one that goes with the Panelrouter. And what can the Panelrouter do? Well, if I go to the next page here, you can see that here I have wires. Those here are the wires between the components. And on this page here, we've put the wires into the wire trace, and you can see that the components are connected. So this component up here, the push button, has got two connectors, and those are the ones that the wires go to. So that's what will be in this one here. And what do they actually connect to? Well, if I go in here and have a look, you can see that all our mechanical symbols, they have connection points. This is a connection point, the physical connection point of the components. I think that I might see them here, but I don't. But when I drag it, you can see that some wires, some virtual wires will pop up, and those lines here, they represent actually the connections to and from this component based on what we have in the diagram. And if I take this one here and go to the diagram, you can see that in here I have this component here, Q1, and I have all the connectors, and I have a reference to some of the rest of that component. But you can see that this component has got a lot of connectors, and all those connection points here they must be on this mechanical symbol here. And right now it's not so easy to see because I think I set them invisible. But if I go up here, you can see that I could go up here and say I want them to all names to be visible. And when you see that, you can see that the names here of the component A1, A2, 1, 2, 3, 4, 5, that's a funny position, but all those connection names, they are here and they are where you want to connect your wires. Just as you see in the diagrams, you can see that I have connections to those connection points. Because the idea is that I do my schematics here, just as I normally would do. And the schematics, as you know, is where you see and show how to connect the wires between the components. And I have a wire going to connection point 1. I have another wire going to connection point 2. And if I zoom out, you can see that all the connections here, they are shown in my diagrams, and that's what you do in your schematics. And that's not nothing secret, and that's nothing new for you, because that's how you connect the wires in the diagrams. But the trick is that sorry, that when we go to this mechanical page here, we can see exactly how or where those wires are. Because one thing that we cannot see in the diagram is we can see that things are connected, and I can also take out some article numbers on those wires and all that, but I cannot see the length of the wires. And that means that even though I do make this mechanical drawing here, then I cannot see the length of those wires, but I can do that when I use the Panelrouter. And just to go back here, you can see I have my wires here, but the quantity, the length, that's 0, 0, because well, I couldn't put it in here. Well, if I could do it, I might type it in and then I would have a length for it, but then I would still not know where I wanted to put it mechanically or physically in the panel. So that's what I can do here. But as you saw just before, the connections to the components, if I start dragging those components here, well, then I could see those wires and what can happen and what can I do with those wires here. And that's what we're going to go through during this webinar here. So the Panelrouter, if I go up here, I have the Panelrouter here. It's a tool. It's a built-in tool. And if I click, the window will open on the other screen. But if I click, you can see that all the wires came in the trays. They're the brown ones here. And now they are here. And we'll go through the settings and all that up here in just not a second, but a couple of minutes. So I'll just close it right now and see that now we've put those wires in so that you can see them. And you can see that those are the wires. They are here. And if I click here, you can see that wire goes all this way around, and that wire here, when I highlight, goes all this way around. So those are the wires that are connected to this component up here. And I can highlight one wire at a time and look at it here. If I go in and look at it here, I have the length in here. You're not going to read it from here, but just to show you that the length is actually written into each wire here, so that we can take it out later. And again, I'm going to show you that. But the length is here, and I can simply see it here. And I can see all different wires that are between the components. It's in the trays now because that's one of the things that I have set up. And I'll just zoom in a little bit so that it's easier to see things when I open my dialog again, because we're going to go through some of the rules that we have here. Because if I go up to the Panelrouter once again and take it from here, you can see that what I have done is that I have routed all wires from my diagrams. I have routed all cables. If there were any, I could route cables as well. In this project here, I have cables going from here. And the reason why those connectors here are highlighted is that I have said that I want to show cross-page links, meaning that something is supposed to be connected to this those terminals here, but it's not on this page here. And normally, as you would know, I would connect external components to my terminal rows, and I could select then not to show those cross-page links on the terminal rows. But as you can see here, this terminal row here has got a lot of connections going out from the panel as well. And whether you want to highlight them or not, that's simply your choice. But what I have done is that I have routed all those different connection types, wires, cables, jumpers. We'll go to them later. And then I have auto-routed, and I have used trace. If I didn't use a trace, you can see that then it would just route like this. I'll still have, they would be angular. It would not just be the cross connections as you saw before. They're still angled as that. But if I have trace, I would put them in the trace. And in the trace, if they were very wide or so, I could use axis, and then they will be put in the middle of it. But here they will optimize and follow the edges of the trace. But when that would be just a remark from me. When I go through it, there's not really a big difference on the length. So I don't think in small projects like this one that it really does matter. But yeah, you can try that when you get back from the webinar here. But that's what it does. And then the air links, as you can see here, those are the links that I showed just before. And those air links, by the way, they have been in the program ever since the very beginning. And right now, this part of the program here, this program here is version 22 of our program, and we're just about to release version 23. But those air links here, they have always been there because we've always known how components are connected in real life, but putting them in the trace here, that's fairly new. So and that's why some of you may not be so familiar with it. So get rid of those once again. But then again, what do I have here? Point number one, if I have some wires that were not routed, they would pop up here on the errors tab. And there are no errors here. I probably used this project before, so that's it. But I might, and you might also find it interesting to go through some of the other tabs here. I'll take them backwards, and then you can see that I have a tab here called components. And if I go to the component T1, for instance, that's the small connection to external supply T1 here. If I click on that one, you can see that all connections going from this this component here, they are highlighted on the page here. And if I take one wire at the time, you can see that right now I can highlight that particular wire and see all the wires that I have connected to this component here. You can also see that all those wires here, they have a length, and that was the length that you saw just before. And this length here is simply based on the physical length that I have on this tray here, because when we make our mechanical pages here, our mechanical drawings, or what we call general layout, GA, or general arrangements, we put them on pages that are what we call GRP or mechanical, and they are made to measure. They are in the scale, and this one is in the scale 1:4. And all those mechanical symbols here, they have the right size. And right now, the symbols here are flat. I might have made them in a like a wireframe model and put them the connection points in a height. But the ones that I have right here, they are actually flat, and I'll compensate for that later. And that's one of the things that I'll go through. But right now, this is a length that I have at the bottom of the tray, and from this X and Y position here. So, and in this way, this is simply the length of of this particular wire going from this connection point to this terminal here and showing up here. So that will be the wires going from that one. If I go further down and have a component like this Q1 that we looked at just before, then you can see that all the wires that go from this component are highlighted, and once again, one wire at the time, and then you can see where's that wire. And then you know that sometimes when you look at a wire, you said, was that how I was supposed to, or what I really thought about this wire when I made my schematics? Well, if you press down the Alt button and click on this one again, then you can see that you'll highlight it in your diagrams. So if I release the Alt button and I can click that one and Alt and click, then you can see that this is a wire in my diagrams. And a lot of times when you look at your diagrams, you make your diagrams, I take it, a lot of times with dots. And those dots here actually mean that you don't really care. You maybe you do care, but you didn't show in your diagrams how you're supposed to make the connection here. But right now you can see that this is how those two components are connected, and that's probably also what you'd expect them to be. And when you look here, that also looks quite okay and quite as expected too. So all those wires here, they are in here, and you can examine your diagrams and see, is this what I really meant to do? And is that the expected connection? And sometimes you have an idea of how should those components be connected, especially based on the layout, because you want to optimize also yourself. You want to optimize on how to put the wires in here. So that's what this thing does. And by the way, as you can see, we don't cross the wires here. So it might have been a shorter wire going from here and then down here, but we don't put the wires to cross the component. So it will go up to the tray, and then it will take this route here and to go down here. So that's how it uses the trays. But and again, this might be the most optimal route, and yeah, so let's just leave it that with that one here. But we have a tab here where we can examine all components, all individual components connections, and this one here, and we can take all connection in one highlight, or we could take one connection to highlight at the time. We could also go in and look at nets. And if I say net, we mean that every potential that we can identify as one net, and what might be everything marked with L1, it's got the same potential. So if I go in and highlight and go in again and highlight it in the diagrams, this L1 here is connected to that one, and this wire here, and we have someone on the other pages as well. Or those nets here, they have the same potential. But we also might have, and I'll just close this one here and go in and say that if I look here, I have this wire here and this and this. Those two wires, three lines, they also have the same potential, and that's also a net. So when we go in and look at nets, we base it on the schematics. So that's what we can see here. And then again, the last thing that I just wanted to show in that connection was that if I look at the nets, that's one thing, but I could also look at classes, because when I want to optimize this, I need to have a couple of tools. And one thing is that I would like to have the most optimal way of putting those wires in the trays. But I must also obey to that I don't want to mix very different levels of potentials in the same trays. So if I have signal wires and I have some power wires, I want them to be separated in my wire trays. And one of the ways that I can do that is to divide all my wires, or the critical wires anyway, into what we call classes. And they're a little bit different from the nets, because that's what they are. And in this one here, I have simply gone in and say we have something that's without any class, but I have some wires to which I have added the power class. That's a property simply to say that all those wires here, they are power lines, And all those wires here, they are signal lines. And then I have invented a third class here called XXX. And those classes here, they're really the next thing that I want to go into. Because what can I do to control my wires here? And the secret to control the wires is those classes here, because I cannot go in and control a net or a certain potential. That's not possible for me. Also because I would have far too many nets. But what I can control is those classes here. So how to do that? That's what I'm going to show you here. So I'll just clear all and exit here as well, because the classes, remember that. When I log in here, then if I go to this page here, you can see that all my wires here, they have, just like my components, they have a name, or you could add a name. They have types, they have article numbers. And the article number is not something that you must do. It's something that you may do. It's something that you can do. Simply to say that if I know that I'm going to use this wire type on this connection on this wire, why not just add it to the diagram? So that's one thing that I have done. But I have also done, and on this tab here called line data field, I have what we call a routing class, and this wire here I have assigned it to routing class power. And that was that one, and the same I think with this one is also power. And I could do that by simply, go in and select all wires here, and then up here you can see that those wires here, they are all power wires. So in that way I can control them. And if I go to the next page, I know that all those pink ones here, they are the class called XXX. And if I click in here, you can see that I have power and signal. They are selectable from the list, because that's two classes that we identified. But if that's not enough for you, you can simply type another class, and it might be XXX or 24 volt or whatever. So, but you can type your own classes in, and as soon as you type them, they are selected on the wires here. So that's what we have here. And when I go to this page here once again, then I can simply see that I can assign those power classes also to, or those routing classes also to my wire trays. And here you see that I have wire trays without anything in them. And those wire trays here, they are open to all routing classes. But then I also have wire trays that are assigned to specific routing classes. And that means that in this one here, I can only have signal wires. In this one, I can only have XXX wires. In this one here, I can only have power wires. So when I put in my wire trays, I can assign them to one or more routing classes, and then they are only open to those classes, or I could open them to all classes, and that would be okay to go in and say which classes are allowed to be in those trays here. But then sometimes I need also to put a full stop in. And this one here, it's a line, a red line, meaning no go. You're not allowed to go in here. And this crisscross red line here, and the color is important, and the type also, but the color is the main thing, simply means that power class and XXX class, they are not allowed to pass this full stop line here. And how do I use that one? Well, let's just have a quick look once again to see what does it do if I don't do anything. So if I go in here and use a Panelrouter and take it here and look at the power class, for instance, and you can see that the power class right now would take this route here, and it will go down in this tray, and then it'll go to those terminals here. That's okay. So, but remember the route. And if I clear this one and exit, and then I'll take this line, I'll just drag it across here, and I could take it here and say, let's just put it like that was take it from here, and I'll just put it here.
And if I go up here once again, take the Panelrouter and go in and put it here, still on the wrong screen here. But if I take the power link once again, then you can see that right now it takes this route here. So no go line, this full stop line simply means that you cannot go that way. But as you can see, I'll just close this one. As you can see, the signal wires, they could cross it very easily because it was only power and XX that were not allowed to pass this one. So when I go in and say, where do I want to put my wires? I have few things that I can use. One thing is that I can use those classes, and I think that's a very smart way of using it, because I only want to make sure that I'm not having signal and power in the same trace, or any way that I can control them. So that's what I can do. And that means that the secret is to use those power classes. Routing classes, I simply add them to the wires, and then I can subsequently add them to the trace here. And let's just have a small look at the trace, by the way. When I make my mechanical page here, I have put my panel. Maybe it was easier to see without this highlight here. So I'll just clear everything and exit. And if I go to this this page here, when I've made my panel, I have put the panel and the trace in one layer, and then I have put all my components in another layer. And it's simply because when I move something, I don't want to move everything. I want to be able to control and select only one thing. And the thing is that when I have a panel and I use it as a symbol, if I click anywhere on the symbol, I might select the panel and then everything will move. So that's the reason why I put the panel and the trace in one layer, and the normal components in another layer. And I simply use the layer function to do that. And then again, those wire trays here, they are, I'll just go up here, they are this type of line, this not filled out but empty frame here. That's the type that I use for my wire trays. And when I do my drawing, if I'm really good, I can go in and select those wire trays from my database. And if I do that, I could put them up in the pick menu, and then I could simply say that this one is 20. Now that's a smaller one, but this is a wire channel in Danish. And then you can see that this is very, very small. So that's not right now. But if I put it up here with the right article numbers and the right data is in the database, then this tray here would get the correct size, the correct width. Because what we're going to in just a few minutes is that we'll look at the output here, and in that connection we'll also check that the wire trays are not too filled up. So when I do my drawings, I want to put my components in the right size and the right scale, but I also want to have my my trays in the right size, because in that way I can check that my trays are not overfilled, and that I have empty space if I wanted to make expansions of this this small panel here. And you can see there's plenty of room for it yet, so so that wouldn't be a problem. But I can put them in, and I think it looks better if it has the right size. I think it's more correct to see it that way. But I still have a few tricks that I can use for it. But let's have a look here. But when I place them, I might use article numbers when I place them, and that was what I could. And as you can see, if there are no routing class, it's open to everything. Whereas the ones that I have assigned a routing class to, they might also have been with article numbers, but they are only open to that specific routing class. So so that's it. But the mechanical page, it's just a mechanical page. Everything is made to scale, and I have put things in different layers, and the Panelrouter doesn't really care whether it's in one layer or the other layer. That's not what it looks at. It simply looks for those routing classes, so that we know where to have things. So that was a secret. But that's one way to control where things are. The other thing that we can control, and I think that if you're not familiar with that, you'll just get the quickest walkthrough here. If I have my connections in here in the diagram, when I use a dots, we don't really care about how to make the connections. The dot shows that the connection points here are connected, meaning that we have the same potential in those two wires here. But exactly how it's connected, we don't really know. But the program thinks we have what we call a net navigator, and if you haven't seen that one before, then now it's time, and I think you should use it sometimes because it's pretty okay. As you can see here, net, those wires here, the same net. Those wires here, the same net. Those wires here, the same net. But if I look at connections, you can see that here I have a connection going this way, and this one here goes from up here down to that one. But if I take this one here, also the same way, if I take this one here, it goes that way here. And the reason for that is that when the program interprets those dots, it will simply look at the dots and say where the dots are the shortest. That's where the wires are double or parallel, so two connections down here. And this wire up here, this line up here, and that line down here, they have exactly the same length. So the direction in which from which it reads the diagram means something here, because this is simply the first one that it will read, and then, oh, okay, we'll just take that one. That's the shortest one then. So, but it might just as well have been that one here, meaning that you don't really know how things are connected here. So, and that's we know that that's not really a problem, but we do know about that. But if I wanted to control exactly how these were connected, I could select them, right click, and then I could make dot to branch in this area here. And dot to branch means that I could make or select this, we call it mounting correct, or a bend showing how things are connected. And the trick is to see that where the arrow is pointing to, we have double connections, meaning that if I go up here, take connections, you can see that this would be both wires. This is one wire, this is the other wire. And if I do the same thing here, you can see exactly the same thing, because that's how this bend is made. And we could go in, select one, and use a space bar, and then I could simply change it, and then you can see that I would have two connections down here. And if that's how things were supposed to be connected, I would show it, or I should show it in the diagram. And in that way, I would have no doubt whatsoever about how things were supposed to be connected. And you can see that this is how it was that right now. And the trick is, and the reason why I show this to you, is that when we use a Panelrouter, this is what the Panelrouter uses as well. So when the Panelrouter looks at the diagrams, it interprets it. It uses its net navigator. It's the same code actually, to see that how are things supposed to be connected. And this connection is what it uses when it routes the connections in the on the mechanical page. And as you can see down here, information, this is a connection going from that point to that point, routing classes, so on. So if I click on that one, I have this connection and that connection. Both connections are in routing class XXX. So I know everything about the connections, and this one here is also the same code that when you select wire numbers and that, if you do that, this is the same way that it interprets the diagram. So if you sometimes say, how come that it will make my wire numbering in a specific way? Well, open this net navigators up here, and then you can have a quick look at and see that this is what it looks like. So you can save those nets, you can print them, or you can just use it to see here. But I think this one here was important for you to see that this is how the diagrams are interpreted, because that's what we're going to use here. So that was just the intro to it. So we can route all those wires. We can route them on this page here. we have the different routing classes, and those are here, and that goes for wire trays and wires, etc. And then we have the different things that we also have in here, because we can route wires, we can route jumpers and cables. And I'll just need to zoom in, because that will be the last thing, because you can see here that those here, those are actually the jumpers. They've been routed here as well. As long as we have connections between the terminals here, those are the jumpers. And I think that you can see that this jumper here will be a little bit difficult to take that one. And how come that it looks like this? Well, it's something to do with that the connection here. I can take it from this one here. I'll take that one. I can right click and go to the diagram, and then you can see that in here someone forgot about what's in and what's out. Oh, that's not the one here. But this is a reason why things are wrong. Is simply that there's a mix up between internal and external side of this this one here. Yeah, it goes from in to in. No, I think something is wrong in this connection here. So yeah, that's, you see. So the connection here actually goes to this one here. It should go up to this connection here. I'll have to take it from here and take it here, take it out, and then sometimes, you know, when you want to do something, you cannot do it. I wanted to go in here, and then it would be right, so that when I go back to this one here and I can do my panel routing, you can see that right now it looks okay. So that's what I wanted to show you. So just out once again, I cannot zoom when I have this one open, but I'll just close it. So and then say that this is what my connection should be like, and you just saw that with the small jumper. So that's the last one that I wanted to show you on that one, because now we have everything here. And as I told you just some minutes ago, all those wires here, they're actually based on a flat 2D drawing right now. And the wire length, they are also at the bottom of the tray, and this is also at the bottom of the panel, this connection point here. And that means that right now the wire lengths are not good enough. So what can we do? Well, when those wires are routed, we have a Panelrouter output here. And in this last part here, we are going to select all those components here, all those wires, and then we will go in and have a look at what can we do. Well, first we have to go in and say that the wires, we need them to be longer. We'll need them to go from the bottom of the tray up to this connection point. And right now we go in and say that default height of all connection points or of all components are 50 millimeters. That means that when we have this wire length that we just created a couple of minutes ago, we add 50 millimeters at one end and we add 50 millimeters at the other end. And if that's okay, we have this height in that we read in the database. We have simply default length or default height. But if we have a component that's different from that, or so much different, more different, that you need to add something, then we'll put in a specific height in the database. And right now we have none of those components here that have that extra height. But let's just go in and have a quick look and say that if we take this one here and go to the database and say that in this component we can go into this component here and say that height for this one, we could call it 90 millimeters. This is our motor protection unit. And if I change that to 90 instead of 50 as we just had before, and I'll just right click again and go into my Panelrouter output, and it should have been there before we did this, but logically. But then you can see that this component here, now has a different value in the database, or something that differs from those 50 millimeters. It might be 50, but there's a value in the database. And then the wires from this component or to this component, they have added 90 millimeters at the end. So in this way, the wires, they become longer, so that they can fit to this one here. So that would be point number 1. All components, we have a height in the database when we don't have specific wireframe symbols, but if the symbols are flat, we use this height in the database. Then we have trays, and the trays that we have, you remember that some of the trays that I had, they had a article number already added to them or on them when I made my mechanical drawing here. And that part number, that article number, that's read directly from this page here. So obviously that wireframe, we know about the size of that one. But I can select a default tray for those trays that I didn't select any wire number for before I placed it here. I could go in and select that one, and then I have this one, means wire tray in Danish, and it's 25 by 40 millimeters. That's a space that we allow for it, and 25 millimeters in height, 40. And that means that if I look at it, the wires in it are not very big. But I can go in and see that all the other ones here, they are not very full. So 9%, and I allowed 55% fill in my trays before I get a warning. And if I change that to 5, you can see that those trays here, they are more full. And you can see that if I click on them, I can highlight them in the diagram. So anything that's too full, I get a warning. And if it was 55, then absolutely no problem. Those ones here, they use a default tray. That's why we have the red mark at the top corner. And the other ones, if I change that one, you can see that they get a red mark up here just to show that you have a warning. So that would be the same thing. But the check here is simply to see, what about your trays? Are they big enough, or how is it? And if this tray here was wasn't big enough, you'd have to select another one. So easy as that. And how do you know about the fill? Well, we go in and select wires. And again, the wires that we selected in the diagrams, they would be, of course, respected. And you can see that when I go out here, I have three different article numbers. And the two last ones, they are the ones that have been added in the diagrams. And this top one here is a default wire, because a lot of times it would simply be too much to add wire type information, because, well, if I use more or less the same wire type every time, well, I there's absolutely no reason to add it to the diagram, because then you just add data to it that is not, that you don't really get any value of. But if you have some wires that you know that they must have a different dimension or a specific color, maybe that could be important, then add it to the diagrams, because then it's in the diagram, and then you have those article numbers here. And wires in the database can have a diameter, and then you know how big they are, so that you know how full are your trays. And when I go in here, you can see that every wire has a part number now. And this wire here goes from that connection to that connection. And then the next one goes from this connection to that connection. So you have every wire here, every wire that we have in the program, in the project, sorry, they are in here. And then we have the length of each of those wires. The first routed length at the bottom of the tray, plus the 50 millimeters at each end that we had here. And then we could add again extra length at the end of the wires here. And you can see here that if I change that to 5, for instance, then you can see that every wire length changes. If I or get it up to 50 again, you can see that those here are changed immediately. And that means that the wire length will be the routed length at the bottom of the trace, plus the distance to the connection points, plus this added length that I have here. So so if I have this one here, you can simply see that I get it here. So this one here, and if I put 5 millimeters here, 5 millimeters at both ends, 2 times 5. And then I also have, if I had 5 millimeters between wires, it would suggest to me that I could replace it with a jumper instead. But when I have added those data here, I can go to this one here to see how many meters of each wire type should I order. And all of this, I can export it to Excel if I want to have a list of each wire going from and to and the type of it. And then I could do it directly from here. If I had cables, I could go in and take cable wires going from and to. I could have that would first be each wire in one in one line, and then I would have all the wires per cable. And if they were too far apart, I would get warnings. And then again, a parts list. But more or less the same idea. But I would get some checks that the wire, the individual conductors in the cables were not too far apart. I could get that from this list here. And then again, I have my jumpers. And default jumpers, once again, all the jumpers that I used in the diagrams. And then again, if they didn't fit with the length that I had put up in my database, I would get a warning. So you saw that they were routed here, and now I changed it before I got the warning. But if I had the other one, I'd get a warning because it would simply be too long or much longer than it is in the database. So now all the wires are routed in here. And I could also go in and take one list here for wire marking if I only wanted to know the line type and markings at both ends, either to, from, or from to at both ends, you know, CL or CB. So I could put that in. The same with the cables. But what is more important is that we talked about this Panelrouter here in conjunction with the ready-made or ready-to-make wires, and you can send it to. There's a company called Cat Cable. That's a company that runs a big factory somewhere in Germany. I don't remember where. But if they get this here, you can go in the database, and I think I had, now I deleted it from mine. But if I had wire sizes for the wire types and colors, and some more wire type and size and color in my database, I could simply add it in here, and then it would know exactly how it was mapped to their database. But right here you can see that it knows again about the connections. It knows that the direction here is from up right and up left, or down right, down left. There would be something too, because when you get those wires here from Cat Cable, for instance, it's important that you can read it. So the direction of the text is pretty important. And when we collect the data here and have it in this tab here for Cat Cable, it's simply ready for them to import into their. They have another program that you get if you're a customer there, but then you simply go in and add the extra data that you might need for it. That could be the rules that you wanted to add to it, and then you can export it and ready for them to manufacture those cables here. We also have a Comex Alpha. That's one one type of those COMEX machines that can make those wires. And again, do you want it to be reference designations and from and to, or do you want it only to be from or to, from and to, or from or to, or you had a wire number? If you had that in your diagrams, you can see that you simply put it in here and have it in the list. That again, you can export. Or COMEX Zeta, that's another machine of those. And again, do you want to have wire numbers or from or to? You can see that here we think that we're going to print 3 times at both ends. And if we want to put in reference designations and from and to, you can see that some of the wires, they're simply not long enough to fit 3 prints at both ends. So depending on what you want to have here, you could simply go in and take it from here. And in this one here, I have some of the, obviously I did collect them, but some of the wires that I used were blue or some were white, so I'm going to print with white. So in my database, it's simply set up that if I use this wire type, blue, I need to print white. Or if I had a white one, I would print in blue or black or something that could be read from it. But in this one here again, you can see that depending on which type of termination that you want to have, whether you want to have ferrules or only those, you have some small extra tubes that you can add on it. I don't remember the English word, I'm sorry. But then you can simply go in and sometimes you'll see something is different in here because you might not be able, or the machine here might not be able to put it on automatically. But as you can see, this is simply what we can have in here. So that's it. So when we make our drawing, we simply go in and we put all those wires in according to the rules that we set up, and that would mainly be this routing class. And then we'll go in and check, is this the right position of it? And then we'll route again or put some more of those obstructions or whatever they call the full stop lines in here. Or we might go in and work a little bit more with the diagrams and that, and route the wires and say at some time we are happy with it. And when we're happy, we'll open this output thing, and then we'll go in and put in, check the trays and check the wires, check the jumpers, etc. And when all that is okay, we're simply ready to export it to some of those outputs here. And what I want to say to you, according to this here, is also that if you have other suppliers that can supply you with wires, then you're very welcome to contact us, because those are companies that come to us and say, we can, if you can deliver it in this and this format, we can manufacture those wires for you according to that. So if you have some other companies that you work with and you can get this format out of them, then please feel free to contact us, because that would only be a plus to our product as well. But this is what this Panelrouter can do. I think that I'll just go through a few small more things before we finish this, because I think there's a couple of things that I would like you to see as well. And I'll go in here and I would simply, no, I'll just open another project here. Because if I go in and start a project here, it's so that when I put in components, I can take a component here, a what's it called, a motor, and put it in and give it a name. And I could take a contactor here. I could take it, I could put it up here and go in here, and I could take this one here simply because I know where they are, the ones that I want to use. Put that one in, and I could take some terminals, and I'll take this terminal here, right click, multi-placement, click and execute, and I'll call it X1 colon U and control question mark. Okay, and then I have this here. And if I go to this page here, you can see that I have all my components here, and then I could put them in here, and I could take those components, put them in, and those mechanical ones are here. And if I took my panel router, you can see that everything would be connected here. I cannot use the trace on that because, well, I don't have any trace here. But this is exactly what I could do in here, and you can see it will find exactly the connectors that I have here. But if I didn't use this one here, this symbol here, but if I instead had a symbol that was called F1, because that's what it's going to be, and I would just go up here and I could say that I want it to be 40 by 40 or something like that, 40 by 30, because it would be like that. And then I'll put this one in, and I would call it F1, and I would go in and check the article number or type. No, I thought I had it here. Here, this one here, because it needs to have that type here. If I do that and I'll go up and use a Panelrouter, then again you can see that right now, it doesn't really work because I don't have the connection points. I could add extra missing pins. If I wanted to do that, I could reroute. I need to go in and open it again, and then it would go in. No, it still wouldn't do it because no, that's okay. But if I do that, I could go in and use. I thought I could do this. I can't, but sometimes I could do it, and then it would simply add extra, or it would add one pin in the middle here, and then it would route all the wires to that specific point here. And if the wires would be like this here, I should, then I would route all the wires to that point. And if it's in the middle, it might be okay. But you can see that if my components would be up here and I would go from this and I would do like that, and I would have some other wires going from the bottom, then if all wires were routed to the middle, some of them would definitely be wrong. So it doesn't work in that way. You'd have to go in, and it's simply because it's got the wrong component group, so it doesn't recognize it as the same component here. That's the reason why it doesn't work. But if I do it, it's not okay. It won't be okay. It might be okay just to get an idea of what things are, but components or symbols must be correct, so that if I take this one, as you can see, it has all the right connection points, and it has them at the position where those connection points are. And if I just go in and make them visible, once again, you can see that those connection points are the connection points that belongs to this component. I definitely, that's important for me to say, I definitely don't need to make the symbols as detailed as this one, not whatsoever. I might go in and right click and edit this symbol here. I might go in and say, I need to have a symbol like this one here, but I can make still a box and say, this is connection point number 1 and this is connection point number 2. The only thing that's important is that they have the right position, more or less the right position. And you can concentrate only on the XY position. You don't have to elevate it in any way. But just put them in the right position and with the right names, because if they have when they have the right name, the Panelrouter can find those connections, and then it will make the right connections to and from those symbols here. So the mechanical symbols must have the right dimension as we know it, but don't make those very simple ones that are only boxes. If you make your mechanical symbols, and you might still want them to be quite simple, you could go in and say, at the top I have 1 and 3, and I have to go in here 1 and 3 and 5 and 97, for instance. And if you had at the bottom, you might go in and say that you have 2 and 4 and 6 and 98. So if you want to do that, you could go in, and would be fairly easy to make a more correct mechanical symbol than that one. But if you don't have mechanical symbols with the right connection names, well, forget about using the Panelrouter for something that would make sense. That would be the last words. I hope that it made you a little bit wiser. By the way, in the Panelrouter, there's a help. That's a user manual for it. And what I have told you, shown you, is more or less in the small manual as well, which you could read. Something to read as a night story. But I hope that it made you wiser. And again, if you have questions, feel free to contact us. Thanks for now, and thanks for staying tuned. Bye-bye.